Hello friends, welcome to Engineering Funda family. In this video, I will derive inverse Fourier transform equation from Fourier series. In my last chapter, I have explained Fourier series. If you have signal x of t, then one can represent x of t signal in form of Fourier series as per x of t is equals to summation where k is ranging from minus infinite to plus infinite ak into e to the power jk omega t. Here ak, that is Fourier series coefficient. Now with this Fourier series equation, if you carefully observe, here we have omega. And what is omega? Omega is 2 pi f, or one can say omega is 2 pi by t. So if you substitute omega is equals to 2 pi by t, then this Fourier series equation, that will be x of t, that is equals to summation where k is ranging from minus infinite to plus infinite ak e to the power jk 2 pi by t into small t. Here I have placed omega is equals to 2 pi by t, right? Now here if you observe, we have 1 by t. See this 1 by t, that explains drift in frequency. Let us assume 1 by t, that is delta f, where delta f is drift in frequency. So if I substitute 1 by t, that is equals to delta f, then this Fourier series equation will be summation where k is ranging from minus infinite to plus infinite ak into e to the power jk 2 pi delta f t. See here 1 by t, that is equals to delta f, that I have substituted. Delta f is drift in frequency. Now here I will elaborate this Fourier series coefficient ak. See Fourier series coefficient ak, that can be expressed as per 1 by t, where integration is having limit from minus t by 2 to t by 2 x of t e to the power minus jk omega t. Here Fourier series, that one should know, that is expressed for periodic signal only, and for periodic signal duration is t. Here this integration, that is having limit from minus t by 2 to t by 2, that I have considered, but one should know this limit, that should be there for one cycle. Let us assume this is there for minus t by 2 to t by 2, and that is how we can express this Fourier series coefficient. Now with this Fourier series coefficient, see 1 by t, that we have already considered as drift in frequency, and omega is equals to 2 pi by t. So here now I will consider omega is equals to 2 pi by t, where 1 by t is delta f. So if I place 1 by t is equals to delta f and omega is equals to 2 pi by t, where 1 by t is delta f, then Fourier series coefficient will be delta f, that is 1 by t. Integration is having limit from minus t by 2 to t by 2 x of t e to the power minus jk 2 pi into delta f. See this 2 pi into delta f, that is replaced as per omega. Omega is 2 pi by t, where 1 by t is delta f, right? Now we have Fourier series coefficient in form of delta f. Now what I'll do is I'll substitute this Fourier series coefficient in this Fourier series equation. So this is equation number 1 and this is the equation number 2. I will substitute equation 2 in equation 1, right? So if I substitute equation 2 in equation 1, then here you can observe we have summation where k is ranging from minus infinite to plus infinite. I have placed ak value, that is Fourier series coefficient, over here, and this into e to the power jk 2 pi delta f t, that I have placed over here, right? Now you need to understand this equation. See Fourier series, that we use it for periodic signal only, while Fourier transform, that we use it for periodic as well as aperiodic signal. So here first of all you need to consider time duration, that is going towards infinity. If you don't have periodic signal, then this value of t, that will go towards infinity, right? So with this integration, now limit will become from minus infinity to plus infinity. Here for Fourier transform, now I will be replacing this summation by integration. So here I'll be replacing this summation by integration, right? Where integration is having limit from minus infinity to plus infinity. One more adjustment that I'll do, that will be k into delta f, that is equals to frequency, right? So this constant k into delta f. So here we have k into delta f, you can observe. So that will be frequency. This k into delta f, that will be frequency. And here delta f, that will become df. So for this summation, we have delta f over here. So instead of this delta f, I'll place df for integration. So if you apply all these basics in this equation, then your equation will become x of t is equals to double integration. See, first integration, that is having limit from minus t by 2 to t by t. As per t is going towards infinity, now that integration is having limit from minus infinity to plus infinity. This summation that I'm translating in integration, where integration is having limit from minus infinity to plus infinity. Instead of this delta f, I have placed df. This is x of t. And here we have e to the power minus j omega t. See this k into delta f, that is f. F into 2 pi, that is omega. Right? Into t, that is how it is there. And here we have negative sign. And here we have positive sign. That is how it is there. Now, if you carefully observe this much term, so that is Fourier transform of x of t. And that is x of omega. Right? So instead of this much integration, I can replace this much integration by x of omega. So here we have x of t in form of x of omega, right? And here this integration that is happening with respect to df. In inverse Fourier transform equation, we can replace this integration of df with respect to d omega. One should know omega, that is 2 pi f. So if you have differential term, then df is equals to d omega by 2 pi, right? If you provide differential of this, then d omega is equals to 2 pi df. So one can say df that is equals to d omega by 2 pi. So if I replace this df by d omega by 2 pi, then this x of t, now that will be 1 by 2 pi. Integration is having limit from minus infinity to plus infinity. X of omega e to the power j omega t d omega. And this equation, that equation is equation of inverse Fourier transform. And one should know inverse Fourier transform, that we use it to identify signal in time domain from frequency domain. So here we have signal in frequency domain. By having this integration, we can identify signal in time domain using inverse Fourier transform. So that is how one can derive equation of inverse Fourier transform using Fourier series. I hope you have enjoyed this session. Still, if you have any confusion, just place that in comment section. I'll be happy to help you. Thank you so much for watching this video.